Well, good evening, and welcome to the Thursday, September 19th, 2013 edition of the Smart Scarecrow Show. And for those of you who have been marking the time, the Smart Scarecrow Show has now officially been broadcast for 5 years. Kind of scary when you stop and think about it. Should have a pretty interesting show tonight. Russ Gries is going to be our feature presenter. He's got a lot to talk about. I hope we're going to get a little bit of an update from him on what's happening with the pulse motor build off. I'm hoping we're going to get a little bit from him about what's happening with the breakthrough energy movement, which I understand he's going to be a presenter there. But I think tonight's presentation from Russ is going to focus on this 3D printer project that he's been working on for some time. We'll just have to see how he's doing with that. Keep an open mind. Let's see how it's going. But for right now, it's time for This Week in Free Energy with Sterling Allen. So please do stand by. All right, Sterling, have you finished chewing and smacking your lips? You're making me hungry eating your dinner just before showtime.
Yeah, still have a few things stuck in my teeth. But
yeah, well, life's like that. Of course here, I think I'm 2 hours ahead of you, so it's like 9 o'clock here. It's 7 there, and yes, at about 6:30, 7 o'clock this evening, I was chowing down my dinner. So I guess I can't blame you too much. In any case, it's time for this weekend.
5 years.
Yeah, 5 years.
Wow.
We had kind of humble beginnings. I mean, the matter of fact, I think about the first 10 or 15 shows I did. I didn't even bother recording. I mean, I couldn't imagine anybody was really going to be interested in watching this thing as a rerun. And it's kind of taken on a life of its own since then. I mean, at this point, if I don't get a Smart Scarecrow show published, I hear about it, man. I not only get hate mail from the ADL, I also get hate mail from the disappointed Scarecrow Show viewers who are insisting I put on a show. So yeah.
And also, you're hitting the big times now. You were in the mainstream news mention with your interview you did last week with Berlin. That was phenomenal.
I was
a lot of coverage of that.
I was in mainstream news.
Yeah. Falls Press. News, I believe it's called, or something like that.
And it wasn't associated with a bank heist or a Second Amendment protest?
No, it was about LA&R technology, and it mentioned the interview that was done with Berlin on your show.
Well, I'll be darned.
Yeah.
I'll tell you,
That came out yesterday.
Yeah, maybe one of these days that bag of money, that was headed towards Berlin will fall in my lap. What do you think the chances are? In any case, I'm interested in hearing your presentation on that. I'm going to go ahead and give you full screen. Let you take it away.
Okay. Well, as I mentioned, the highlight this week is the interview you did last week on with Berlin, the two Roberts. They go by Bob and Robert. It was a phenomenal interview. I was glad to have played a role in getting that hooked up. I was hoping to be in on that interview. I guess you didn't get that memo. But that was okay. You did an excellent job. And it got about 5 or 6 stories, all but one of those, or one of them was mainstream press. The rest were the typical coverage organs of alternative media on these types of topics. And I would recommend everyone listen to that because, in my opinion, that was a high point in LA&R history. Those two gentlemen portray themselves as being very knowledgeable, very good in business, having good technology, good knowledge of how it works, and the ability to articulate that both from a specific technical point of view as well as a layperson point of view. They covered both ends of the spectrum and covered a lot of material. They said that they're looking at about being 1 year away from having a prototype that he could then present to some manufacturers to license and roll out, to do the engineering necessary to roll it out commercially. And there's about a 50-50 toss-up as to which technology will be the HHT, which would be for power plants, which is the reactor technology that requires constant surveillance of the technology because it's not something you can just turn on and let it run. Or the other technology is the WET, W-E-T is an acronym, I'm not sure what it stands for their boiler technology that you could heat your home with and possibly power electricity as well. So they're going gangbusters and staying under the radar. They're doing a pretty good job of that. But now that we know that their website posts updates from time to time, they're probably going to be hearing about them more than we have in the past. And so I'm certainly going to be paying closer attention. Other highlights from This Week in Free Energy, or This Week in LENR Energy, I should say, is Rossi talked about direct electricity production with the ECAT, the Martin Fleischmann Memorial Project, politics, some discussion about that, Google Brillouin connection speculations, and Zenardsik interview, where actually I believe that was a presentation, a petition, and a conference, upcoming conference on coherence that will include sessions on LENR. It's over in Europe. Moving on, Infinite Energy, which is the flagship scholarly journal on cold fusion, which is probably the wrong name for it, because it's not fusion, it's transmutation from what I can tell, if that. It is nuclear, most likely. But anyway, that was a magazine started by Eugene Malov, who was murdered in 2004. Issue 111, The New Fire Generation. Headlines include Cold Fusion at NI Week 2013, ICCF 18 report, Pam Boss receives Preparata Medal, John H. Bocri's eulogy, died. Modern electrochemistry and start of cold fusion is his legacy. The molten salt reactor, nuclear energy without fear, appliances of barium and lithium iodine plasma, Ken Shoulders, Ed Storms honored at ICCF 18, and neutron exchange, LENR for cold fusion. They're very good, like I said, at very scholarly presentation of material. I posted a blog page for a big development. I think last week or the week before we mentioned that Turksoder, the motor developed by Atilla Alperin over in Turkey, was allegedly invited to participate by the Turkish government at the Innovative Technologies and Inventions Fair at the Istanbul Expo Center. We got the name of where this is going to be held. It is the Expo Center. And we also got evidence going to their website that it is fairly late in blossoming. They apparently just got the information up about this upcoming fair. People were wondering, usually things like this are planned a year in advance and etc. His booth is number F123 for electric vehicle manufacturers, where he's looking for two things. Number one, a manufacturer like an OEM that he can just basically, here's the plans, here's the money, make these things. He's not looking for money, not looking for investment, not looking for partners, all that's sewn up. He's looking for manufacturers of these things who can make them in high quantity. He says more than you can imagine. The second thing he's looking for is licensees for applications for cars, trains, ships. So, for example, Tesla Motors might say, we want one in our car. They would sign a license deal with the Alperin Group. The thing that's fascinating with this technology, it claims that no plug-in is required. Basically, run as long as you want without stopping for fuel, and a small battery bank, because all you need the batteries for is regenerative braking and acceleration. The onboard generator produces all the energy you need to get down the road, going up hills, etc. So, pretty crazy claim, pretty big development. Be out watching this one with interest. I started a blog page at PezWiki to kind of chronicle these things as we get closer and as it unfolds. He does have a Ustream channel where he will be broadcasting his station live. It's a 4-day event. So that's a pretty big development. Hopefully this one will come through. Prisa Technologies announces Z-Point Energy Solution. For 6 years, Indian couple in Silicon Valley has been working in stealth mode to embody a prototype zero-point energy technology. Shailendra Singh has been theorizing for 18 years. His partner came along, now wife, and helped him embody it into a prototype. The third-party prototype can output supposedly 0.5 watts continuously. Now they've got a crowdfunder page. He did a demonstration of this technology, and I have to say it was hard to be impressed. It's an empty metal box. You got one lead coming from the ground and another lead coming from a lip, and it's lighting an LED. Hard to think that that's not some metallic battery effect. And the 60 hertz sine wave on the oscilloscope most likely is electromagnetic smog. But there are some people who think he could be onto something. He's obviously very intelligent, went to the India equivalent of MIT. Very articulate, hard to understand his Indian brogue. He's got a very strong accent. And that's why he did the voiceover on his demo video. Update on yieldees. I haven't put this in our news, but I'm going to mention to you kind of in a whisper tone that if you go to yieldeesdemo.com, you'll get our
okay,
latest.
Nobody's listening.
Okay. we pretend like we're in the early days of the Smart Scarecrow show, right?
Yeah, it's just you, me, and the walls.
I did do a little update, a blog post that was put up by one of the people who was doing that documentary film of the experience of that attempt to validate the technology in Germany. Quite the fall flat on your face event. But he says, I was urged by Halil to say, hold off on posting anything, give us a month. And apparently they've got some kind of big validation up their sleeves, so hopefully they'll pull through, right?
Yeah, but Sterling, we've been hearing from him. Well, okay, I
18
guess.
years.
Yeah,
another 18?
hey, just give us a little bit more time. We're going to get this working. We just need another few days, another week, another month. After 18, sorry. Next. Okay. I had my piece. I'm sorry. I should keep my mouth shut.
Well, I guess they deserved it. Hopefully they and many other people like them can validate themselves eventually. Tesla commemorative medallion for barter currency ? Dale Pond of Sympathetic Vibratory Physics has a crowdfunding page to launch a line of copper medallions that actually have value. In contrast to today's paper money that has no intrinsic value and is headed toward hyperinflation. Each donation in the project gives you medallions, starting with 3 medallions for $10. They're pretty cool looking. He's going to do Schauberger and other things too. Tesla Academy jeopardized by Colorado deluge, which is called a 1,000-year event. I'm from Boulder, Colorado, where the 20 inches of rain in 4 days they got. Holy cow, and that was measured right by where I went to high school on Greenbrier and Broadway.
By the way, I have heard from the BEM folks, and they tell me that their venue was spared any damage. So any of those people out there who might have bought a ticket, ready to go to Global BEM next month, the best information I have is that their venue is high and dry, no problems. The show will go on.
Damn their torpedoes, full speed ahead.
Yeah, that's right.
The message I got too. Yeah, but Tesla Academy may not fare so well.
Are they in one of the lower areas?
Fort Collins, and apparently it was stormed out and got some problems, so hopefully they can recover from that. That was Michael Riversong. It does that operation. And then off on a bit of a tangent, the polar ice cap, which is supposed to have disappeared by 2013, is 60% larger this year than it was last year. And so that's stirred up quite the controversial conversation, looking at the data on that. I have yet to see really solid evidence that there is global warming. There's certainly climate change, and I see that as being a function of all the tinkering with the weather. These people have the knobs and controls who are playing around trying to play God. messing with things pretty bad. In fact, I would argue that that Colorado deluge was probably either something done intentionally or something that went bad. So for what that's worth, that's all I have for this week in free energy.
Well, that was a sure. I've been shortchanged, man. You cheated me out of 4 minutes. But as far as this weather modification, I'm not sure how much of that I buy into. Now, I agree they're obviously pumping some stuff up there. Some of the videos I've seen where they've actually had planes following these tankers that disperse this stuff. I mean, somebody's dumping something into the atmosphere. I don't know why or for what for. I've heard a lot of stories. I've heard stories, everything from, it has something to do with HAARP and making earthquakes and over-the-horizon radar and all kinds of stuff like that, all the way to, trying to protect us from, invading aliens. I don't pretend to know. They're obviously putting something up there. But, the fact of the matter is the sun goes through periodic cycles. We've seen cycles where there was low intensity coming off of the sun. We've seen periods when there was high intensity coming off of the sun. Folks my age remember when men always wore hats. You did not go outside without a hat on your head. And then along about the mid-1960s, solar radiation was decreased and it became the fashion that men did not wear hats. There may come a day at some point in the very near future where solar activity picks up again, and we'll all be back to fedoras. The fact is, climate change is a normal fact of life. We got to get rid of. We got to get rid of this nonsense of we can solve it by paying a carbon tax. That's the part of it that really offends my sensibility.
Yeah.
I mean, the fact that, the only way we can solve the carbon tax is make Al Gore even richer than he is now. No, that isn't going to solve anything. The human activity contributes less than 1% of the total carbon dioxide that gets pumped into the atmosphere.
Yeah.
That's it.
It's very political, that's for sure.
So, nothing else from you tonight, huh?
We'll call that a show for tonight and turn the time over to your very fascinating guest, Russ Gries, and look forward to that presentation. Enjoy.
All right, sir. You have a good evening.
You too.
Okay, and that was our presentation from Sterling Allen. You're going to have to pardon me for squinting. I'm not sure why, but tonight, for some reason, my studio lights are just bugging the living daylights out of me. I got the same lights going tonight that I have every production I do. And no, Tommy, I ain't been smoking left-handed cigarettes. Gave that stuff up long ago. So it ain't that. It's just for some reason tonight the studio lights are driving me crazy. I have a funny feeling it's going to give me a headache. But, life's like that, and we press on. Our feature presentation tonight is going to be done by Russ Gries. Many in the audience, I'm sure, are familiar with the range of projects that Russ has been working on. Now, I'm not sure how many of his gizmos we're going to be able to touch on tonight. He does have a lot of stuff in the works. I know he kind of wants to focus on his 3D printer project. That's the one that's near and dear to his heart this week, so we're going to focus on that one. But if we talk sweet to him, maybe give him a kiss on the cheek, maybe he'll give us at least a quick update on some of the other interesting projects he's been working on. In any case, I am going to play a special bumper that Russ provided me with. This bumper runs for about 1.5 minutes. I think it's probably going to be just long enough for me to arrange the Skype call in the background. So you all stand by while I do the Skyping, and we'll be back with you in about 1.5 minutes. Well, Russ Gries, I tell you, I don't know what the hell good that thing was you printed, but it sure looked cool.
That's the whole point of it. It's just for fun. Well, that one was.
Now tell me, that's a rattle for your baby, right? That's
it is.
You
Actually,
got it.
My middleest one loves that thing. I mean, loves it. I'm surprised he hasn't broken it yet. It's been flying across the house many of times. Trust me.
Well, I figured it was either that or it was a Christmas tree ornament. I couldn't figure out what the heck that thing was, but I looked at it and said, I don't care what the hell it is. That's cool.
I'm going to leave it to your imagination.
Now,
you can do whatever you want in there. Okay.
Now fess up. Fess up. I know you're running that in high speed mode there. How long did it really take to print a complex object like that? Because that was a pretty complex piece of widgetry you did there.
Yeah. Well, actually, there's a clock in the background. You just missed it.
Oh, right. Okay. Well, I was probably too squinting because the studio lights are bugging me.
Yeah, I can see that. I heard the object there you saw took 33 minutes to actually print, and I'm going to print one while I'm on the show with you, so you can actually see the progress as I show you the printer and talk about other things. So it'll be fun. All
righty. Well, I'll tell you what. I want to hear about all the good. First of all, a couple of quickies before we get off on your tangent. I know you got a bunch of stuff you want to cover tonight, but I got to hear from you. How's the pulse motor build off going? How many people do you have entered? When are we going to start seeing some interesting stuff coming out of the pulse motor build off?
That's a good question, and I would like to take a minute to talk about that. Really quickly, for those of you entering, you can post it at either one of the two forums. If you go to my website, click on the Events tab. It's rwgresearch.com right there on your screen. And if you click on that, go to Events and click on the Pulse Motor 2013, okay, and you'll go there and there'll be the big description of information. There are two different places where you can enter. I have currently moved my particular spot on my forums. It's in a little bit different area, but the links still work exactly. And there's a separate thread that you can post your final video. So if you guys, anybody watching, want to go actually watch the final entry videos, they can go there, and just the final video entries will be there. Somebody in the chat room can probably drop a link to it. And then also there's Tin Man's forum, iaec.formco. And there's the same thing there. There's a thread solely for the purpose of entries. I believe there's maybe two of them over there right now. One of them on my forums, and I know there's probably at least 10 people in total entering, and there's been a fantastic amount of good stuff come out of this build off already. I've met about 3 or 4 new people, and some of their work it blows me away. Gives me brand new ideas. That's always bad, right? More stuff to work on.
And how much longer do folks have? I mean, if somebody was getting off to a slow start and just now was getting into the game, how long do they have before the judging begins?
All right, 3 days, 3 hours, 34 minutes, and 36 seconds.
So if they were going to start today, they'd have to be quick.
It would, but I've seen people throw things together in a day. You can take a reed switch, a little coil, and a VCR head, tape a magnet to it, and it just works, a little battery. That's the simplest thing you can do, and you can enter that. That's what we want to see. People enter the simplest ideas is sometimes the best ideas, and just.
Well, I still got my pinwheel and burrito, so I'm.
Are you going to enter? I'm waiting for a video. I haven't seen it yet. You can't win any prizes unless you post and enter the video now. Okay.
I can't win a prize unless I post a video of me farting on my farting on my pinwheel.
That's right.
I'm pulsing that thing.
Yeah, the pulse motor build off is going really well. I expect to see at least 15 people enter, but I'm sure there's people in the woodworks out there that are going to slap the video up. And don't forget, if you do not get a working pulse motor and you've worked this whole time building something, please post it anyway. You do get 3 minutes. Don't go over 3 minutes. We do that because judging takes a while if you do that. But just enter it anyway. If you've worked hard at it, do it. You're still totally eligible for winning prizes. And I've seen people in the past win prizes that have not fully completed it because they've busted their freaking butt. We like that.
All right. Now, is that it for the pulse motor build-off? Did you get it off your chest?
That'll be good enough.
All right.
I think you guys got it. 3 days. You better hurry up.
I got to get an update from you on Global BEM. What do you hear now? Last I heard from those boys, it's still, show goes on. Damn the flooding. Our venue's in good shape. the show goes on, and I assume you're still headed west to a presentation. Is that not right?
That is true. I contacted a gentleman who's actually in Boulder, Colorado, and he said the campus is fine. So, and he also said we must not be stopped. Okay, this is the field that we are trying to do. We are trying to show the world the new type of technologies that are available to us, and the only way to do that is not let something like this. It's a disaster, and my heart goes out to these people, but it will not stop what we are trying to do, and that is what, you know. I was concerned myself, but that's what he said, and I'm totally with that. That's what we got to do. We got to press on, and you know, keep the people in our prayers. But we got to keep going. It must go on.
Well, I just want to reassure the folks in the audience. We are going to have a presentation by two of the fellows who are presenting this year at Global BEM next week. So, you know, we are still promoting this event. We're still hoping to sell tickets. The fundraiser, I understand the Indiegogo fundraiser has now been concluded. I understand they raised just shy of $8,000. They were hoping to get $30,000. Didn't quite make it. But the word I get is that they have more than enough funding to make sure that the show does go on. I was going to, you know, pick your brains about, you know, pap motors and Stan Meyer stuff and all, you know, I mean, the list goes on and on and on. But I know you really want to do some bragging tonight on your 3D printer, and certainly you have every right in the world for some bragging rights. You worked hard on the darn thing. It seems to be working pretty good. That cute little baby rattle or Christmas tree ornament or whatever the hell it is. It was a pretty cool print job. It was very interesting. I think at this point, sir, I'm going to shut up, turn it over to you, and let you show us what you came here to show us. So you go for it, man.
All right, that sounds good. You can see it right here. It might be pretty blurry, but we'll get to it. That's the 3D printer right there. Quickly on your subject of PAP and Stan Meyer and everything else, I would like to give the opportunity at the end of the show. You tell me when it's time and give enough people to ask any question they like, and I'll try to answer it, because I would like to give updates on those things. But I really want to discuss this 3D printing because it's like endless possibilities, and until you get one and you use it, you really don't grasp the concept. Because I had parts sitting at my house for over a year, and I just didn't want to put the time and effort into it to build this thing. And now I wish I would have, because it's absolutely just, it blows me away what you can do with this thing. Dream up an idea, download Google SketchUp for free, build something in there, take a half an hour, walk up to your printer, print it, half an hour later you've got the object that you were dreaming of. It's fascinating that you can do such a thing. I got to thank my buddy Jeff and Nate Firepinto. Jeff actually sent me a lot of the parts, most of the parts for this build. He actually printed on his printer that he built, and so props go out to both of them for kicking me in the butt and making me get this thing done. Feel free to interrupt this presentation with questions. So Gary, watch the chat room. If you've got a question.
The first question I just posted there in the Skype chat. I don't know if you can see it or not, but that was the first question that came through.
Okay.
What I'll do is
I'll let you read them.
Yeah, I'll post them up in the Skype chat so you get to them at your own pace when it's convenient to you. You know, you might wind up with 2 or 3 of them in there, but that's okay. You know, you shouldn't have to interrupt your presentation every 30 seconds to answer a question.
No, I tell you what, just let me know if they've got some. If you guys want to wait till the end, I'll give you as much time as Gary allowed to ask me questions.
Well, I think what they're spending most of their time on right now is I think they're ranking on Tommy Reed for not being finished with his yet. You know, he was bragging quite some time ago that he was going to have his done by now.
I'm glad that you brought that up because I didn't want to forget. I got to give props to Tommy. I know I gave Tommy a really hard time, but he gave everyone else a really hard time. The 3D printers that are out there, Tommy kind of put them down a little bit further than I would have liked. There are a lot of issues, and you do have to have a little bit more technical knowledge to build one from scratch. But you can buy one right off the shelf, and it'll just print. So don't let that push you away. But I got to give props to Tommy. He did a fantastic job, and I told him that off of public air. But props to Tommy, and if he gets his software built from scratch, That's ridiculous. It's way over what I've got the ability to do at the time. The software portion is actually the most complicated, and that's why he's still not done yet, because these people have been doing this for years, and it's a science that you've got to get calibrated just right with your printer. And it's taken me about 2 or 3 months to truly dial in this printer. Quickly, I'll answer that question. The resolution, the smallest object I can print, I don't really know. I printed off a 1/2 inch by 1/2 inch by 1/2 inch cube, and it was within 1/1000th of an inch. I can't complain about a 1/1000th of an inch tolerance on a printer that I built in my basement. Okay, so pretty good resolution as far as accuracy. It's very, very accurate. The layer height that it prints at is actually 2.5 millimeters, and the width that the extruder is 5 millimeters, and it extrudes just slightly over that. So that's kind of the resolution. I am going to just walk you up to this thing. I'm going to start a print, and while it's running, we're going to be talking about stuff. And I can do that. I can move it around and show you what I got. I'll show you a few of the details on the print head itself. And at the end of the presentation of this printer, I got another little thing I'm working on about 3D printing. So remind me to inform you of that. I shouldn't forget. Let's drag you over here. Let's see how this works. I got you on my block of steel attached to magnet. Alright, so I'm going to take this off here. I'll try to go slow with this so you can see it. I move it back to its position.
You know, one of the questions just came in was, you know, can you only print simple objects like a square or a triangle? And have you still got that baby rattle you printed earlier?
I do.
Show that thing.
Let me
right,
show you some
for those,
of these
for those who might want
objects.
to, for those who are asking if you can print a complex object, how's that for complexity?
How's that? That's all open air. That was printed just like that, and I'm going to print one while we're on this show, which I'll get started in a minute, so it's done. It takes a half an hour.
Takes a half an hour to print one of those, huh?
Well, 33 minutes, but yeah. Close enough. Here's a funnel. All right. You can kind of see it. My wife actually used this for a while until she figured out the hole's too small. She can't fit, so I'm going to print her a bigger one.
Yeah, that's what Tommy Reed needs for his jet engine. He needs it made out of aircraft aluminum.
Yeah. You can print in metal, but not at home, I don't think yet. Here is a pretty complex piece. This is actually the single width of the extruder, which is about 1/2 millimeter wide. And that's pretty complex right there. I'll show you a few more objects later. I want to get this print started. So I'm going to show you the print head itself. Now,
one of the questions that came in on the print head is what diameter is the orifice that spits out the plastic? Do you know?
Yeah, it is exactly 0.5 millimeter. I gotta give props. I gotta give props to Jeff. Jeff actually built just the hot end portion of this from scratch, and I had to rebuild it because I think I broke the wire off while it was moving around. Just bad move on my part, and I rebuilt it. And I was just simply amazed. And he's working on new designs. So if you're curious, get online and look up a hot end is what they call it, and you can kind of get an idea of what they really look like. This is kind of hidden behind a few parts. But basically, there's a piece of nickel chromium wire, which is a heating element wire, wrapped around a piece of brass that has a hole drilled in it. And inside that, there is a piece of plastic called PEEK, I believe. And PEEK is a temperature plastic where the heat won't affect it. This runs at 230 degrees Celsius, which is like 446 degrees Fahrenheit. That's the melting temperature of the ABS plastic, or the extruding temperature. Now, this particular printer, before I forget, is what they call a Delta configuration. It's kind of a newer thing. And I built this. This was a replica of a prototype. Now, all the little details and all the actual building is more custom, but the actual dimensional layout of this was already done by someone else, and I've just replicated what they have done. The other type of 3D printer is what you've seen Tommy Reed. You have an X, a Y, and a Z. So this style I like because it's simpler to build. There's not quite as many pieces. I will tell you that there's not really the best amount of software out there yet for it. This is actually a hacked firmware on this device, so there's definitely some needing to do out there. So if you're a programmer, get involved in this thing. The people can help out. This is all open source, Everything that you see right here is 100% on the internet. You can find it on the internet. It's just absolutely amazing. If you Google Rostok, I think it's Roctock. That's the name, if you will, of this. Now, this printer runs on rails, which has slide bearings. Okay, I can move this by hand, and you can see how it moves. So this is what I call a delta configuration. It runs on a triangulation system, and it's definitely a little bit more tricky to calibrate because it is hacked firmware, basically. But this runs on rails. The newer styles that I would recommend you look up is a Costel. I don't know how to spell it. But basically it runs on a single rail that's made out of that 8020, which this one's like 4060 or something. It's smaller, but I have some 8020. So if I build this again, I'm going to be using the 8020 extruded aluminum and get rid of all these slide bearings and these rails because they're quite expensive. These two pieces are probably the most expensive. The slide rails for sure because they're so long. These are actually a 8mm oil hardened drill rod.
Now, Russ, I happen to know that you're a pretty frugal fella, and you do tend to take the Tommy Reed approach to a lot of things. You tend to use what's laying around and scavenge for materials. But fess up now. How much of your hard-earned money do you actually have put into this thing?
If you wanted to build this exact replica, which again I recommend you build the Costel version, but it's basically exactly the same thing. You're gonna be looking at the $800 range,
Right,
and
so you're a little less than $1,000.
I'm over $800, but
so you're about $800 out of pocket, and I've got to assume that you probably scrounged another $800 worth of stuff because you're a very frugal SOB.
Yeah, that's true. The power supply, a lot of the fans. What else? Well, really all the hardware, like the plywood and all that kind of stuff. The switch here you see, and a few other objects. Yeah, that all I kind of had laying around, but I bet 85% of this I had to purchase because I just did not have the exact particular item that I was needing. But the power supply is just a PC power supply. It's tucked under here, and it locked up. Hold on, we'll wait till the video to refresh. There you go. It's tucked under here. It's just a regular PC power supply. Now, a lot of people ask how much money does this cost to print. Currently, I believe, let me double check. I think it's only a 250 watt power supply. I'm not going to be able to see it because I've got it mounted in there real deep. I think it's 250 watt power supply, so you can calculate how much money that's going to cost you to run this printer. It uses probably close to the full amount. Because you can hear the fans kind of dim down when the heat bed kicks on, which I'll get to in a minute. Now, I did start a print. I wanted to show you something real quick. This is going to start here in a second. Hopefully it's not real loud. Basically, this is the interface right here. There is a regular SD card that you get in a camera, okay? It flops right in this jig right here, and it's got an LCD screen. It's got a push-button rotary front on it. Alright, yeah, I can go through the menus and I can do different options and change the temperatures and all sorts of stuff. And basically, Tommy was telling, that his problem that he had with a lot of 3D printers is you have to have a computer sitting next to it, and it reads from the computer. So if anything gets interrupted in that communication link, it goes down and your print is failed. And I've printed objects up to 9 hours, so, that would really be a pain in the butt. And so this is a way around it. You can purchase this online. It's I don't remember the style, the actual name of this, but if you get online and look up SD card reader, you can actually find it. So it just took off and started printing. If it's too loud, let me know, but I think we'll be just fine. So basically,
I can hear it, but it's not too bad.
All right, this front interface here is actually the whole electronics. That squealing noise will stop here in a minute. I'm going to shut this front. Basically, the electronics is nothing more than our Arduino. Let me grab another one and show you exactly what the Arduino is. The Arduino is an open source, not that one. The open source platform. You can go to Radio Shack and purchase the Arduino portion. Now, there is a shield that go on these. People who know about Arduinos know about shields. Well, the shield, here's what an Arduino Mega looks like, and this is what it runs on. And the firmware is open source, it's free, you can go download it, which is what this that's one reason why I want to build this thing, is because it's full-blown open source. So the Arduino has a shield plugged onto it on the front of it. This shield, what it actually does is take the information that's being fed from the processor in the Arduino, the microcontroller, and it feeds stepper motor drivers. It feeds PID loops for the heating of the bed as well as the hot end up here. And all of that's being controlled on the processor, but the shield takes it and turns it into usable stuff. So it's got power MOSFETs on it, it's got transistors on it, it's got motor drivers on it. Also, I'll tell something. Tommy also was discussing in his stuff that he had a really, didn't want to use people. He saw people blowing up their motor drivers and stuff on this. These are, I'm not going to remember the name of the type, but they're fairly small. They've got a little bitty heat sink on them. It's hard to see, I know. It's got a little bitty tiny heat sink on them. And unfortunately, if you don't cool them, they will get warm and they will get hot. But I've never had an issue with these motors. They stay cold. I mean, literally, there's hardly any temperature change from ambient temperature at all on these stepper motors. I've got a stepper motor here if you'd like to see what they're using. This particular model uses NEMA 17 motors. I think that might have been what Tommy was using. I'm not sure if he went bigger or not. Very simple stepper motor, no feedback. So if something gets in a bind and it all fails, it fails hard. So I've actually been printing this. I printed this. I printed parts for 1 month straight, every day, every night. My wife helped me. I was printing off parts for the conference to build my little levitators. And I printed off 30 of them. And I printed for a month straight, and I had one print fail, and it had nothing to do with the electronics or how it functioned. It's just that the plastic didn't stick to the heat bed. That was the only issue I had. So for people asking, well, how much can you trust this thing? I'll run it 24/7. I'll run a 30-day print straight if I had to, and I trust it. Which is, it took me a while to get to that point, but I've used it enough to trust it. So this model has 3 stepper motors for the arms. Each arm is connected to a belt that you see right here on a pulley on the bottom. And that stepper motor is down here driving this belt. Now again, it takes XYZ coordinates and turns it into a delta configuration. And that's part of the hacked software that, I'm not going to remember that guy's name, but he gives all props to that guy. He's actually the one who came up with the idea and hacked the software and made it work. So the other stepper motor driver, which we're going to talk about, is the filament extruder. So a lot of people are going to ask me, how does that work? Let me move this around. I'll show you. On my particular hot end, I've got a fan down here, squirrel cage fan, and I've got a hose that comes up, and it comes, the black thing that comes up and around. You see it sticking into the top of the hot end there, and then you can see the hose sticking out there. That's actually airflow. What I'm doing is running air across it, and I'm cooling the hot end so it doesn't get everything else around it really hot. This printer could probably print without it, and I've tried it and it works fine. So originally I thought I definitely needed it, but it's maybe not a necessity. But that's what I did to not mount a fan on the end of the end effector down there. I decided to not do that. So back to the plastic extruder. How does that work? If any of you know what a wire-fed welder is, this has a gear, which a wire-fed welder has a bearing. This has a gear with notches in it. Back towards the gear. It has notches in it. That wheel is attached to the shaft to that motor, stepper motor. And then on the other side, I've got a regular bearing. And again, I didn't engineer and design this particular extruder. Someone else did, so props to that guy. Too many different people out there working on stuff. I can't remember all the names, but if you look up Roztok, all the credits are out there for people who've done this. But it's got a bearing, a couple springs, and it pushes that bearing against that shaft, and you put your plastic in between there, which is on a spool like this. This plastic is, and don't remind me to get back to the plastic thing, the other idea I'm going to talk to you guys about today. This plastic is 1.75 millimeters in diameter. And that plastic gets pulled off of a spool. In this case, I've got a tube. This is Teflon. No, nylon. No, Teflon. A Teflon tube. let's see, 2 millimeter inside diameter, 4 millimeter outside diameter. I've got this plastic, comes down here, goes into the bottom of the extruder motor, and it gets caught on them teeth. And again, the software controls when this has to be used and when it needs to be on, when it needs to be off, and what it needs to do. That's all in the firmware. I didn't plan on showing people software tonight. If you'd like to see that, please go and watch the video I have. One of the buddies out there in the chat room can probably find it for me. Find the well, it's in your show notes, Gary. That link to my webpage in your show notes. That is the video that I'm talking about. I do software in that video if you want to see it. All right, back to the extruder. It comes in, gets pushed through here like a wire-fed welder does. Same exact way. It gets pushed up a tube that is also connected with a few wires as well for the hot end. I can open this up. Comes up this tube and comes out right there. Goes into the hot end and gets pushed into the heated hot end, and on the other side of the heated hot end out comes the 0.5 millimeter. You can see I'm printing there. The 0.5 millimeter.
How thick a plastic can you put in there and it still fits through the hot end?
The filament, as they call it, the plastic here. This is ABS. You can also print with it's a biodegradable. PLA it's called. I don't know what the PLA stands for. This is ABS, and this particular model printer and the extruder runs a 1.75 millimeter plastic. That is what you use. The filament is exactly 1.5 millimeters. Now, originally 3D printed started in mainstream basically with 3 millimeter filament. And I believe you can get higher precision and more accurate extruding if you use a smaller filament, so you have more accuracy on how much you extrude out at a particular time, because as you can tell, I'm only extruding parts out right here in a particular spot and laying layers of plastic on top, so you want it to be pretty precise. So I'm assuming the 1.5 millimeter plastic came about for more accuracy. Now, I did never try the 3 millimeter, but most of the people who started in this early did.
Okay, so bottom line is you got to have an extruder head that's of a diameter suitable for the size plastic you choose to use in whatever job you're printing, right?
That's correct.
Okay.
And for clarity, the whole diameter.
I mean, is it common for people to have one of these things with 2 or 3 different heads, and they change the head and the plastic they're using depending on what kind of a job they're going to print? Is that common in the industry?
I'm not going to say it's common, but I'm going to say people are definitely playing with it, probably a lot more than I think, because I have seen printers with dual heads with 2 different colors of plastic. And basically in your software you tell it, hey, I've got 2 different heads and they're this color and I want to print these layers in that color and these layers in that color, and it will automatically place the head in the right spot so you get the multicolored effect. You can buy like rainbow colored plastic too if you want to just have fun with it. But yeah, I've seen up to 3 print heads, 3 different colors, and it's fascinating. This being my first one, definitely didn't want to try that, but I'd say if I built another one, I'd at least want 2. And the reason for that is because they make a conductive printable plastic. And so you could literally print a circuit within the plastic part. It'd be pretty fascinating to play with. I don't know too many people, actually I don't know anybody that's playing with it, but I know they sell the filament, so therefore people are playing with it. But you can get different diameter print heads. They all accept whatever diameter plastic you're using, but the end of it may be, I've seen them down to like 0.2 millimeter width, and then you can print down to like a 1/2 or 1/4 millimeter layer height. See, I'm printing 0.25 millimeter layer height. Now I can go smaller layer heights, and that gives you more precision, more accuracy on the shape of the object. Because if you're building a triangle, or a pyramid I should say, the thicker the layer, the more rigid the edge of the plastic's going to look. The end print result isn't like this perfectly smooth surface. You can tell that it's layer by layer. But let me show you this print, which is something I printed for a VIC bobbin, for those of you who know what that is. I doubt you can see how smooth this is because of the camera quality, but I assure you, if I run my finger down here, I can hear it. You probably hear that?
Yeah.
But when I look at it, it looks really, really smooth. I mean, I'll put it this way: every time I print an object, especially something like this that's complex, I don't understand why I didn't build this thing a long time ago. My buddies should have pushed me over the edge, and eventually they did. This is probably the best, handiest tool I possibly can have.
Now, there's probably some guys out there that have a CNC router that they use to take metal off of billet stock. Is it possible? Have you seen anybody do a conversion to take a CNC router and turn that into a 3D printer? I'm not sure why somebody would want to do it, because it seems like the CNC router actually has superior capability. But I mean, if somebody wanted to do it, do you think it's possible?
Yeah, I do. The thing is when you're 3D printing, I'm laying a layer of plastic on a layer of plastic. There isn't really any force on the print head. When you're milling and cutting, you're going to need a super sturdy piece of framework to make that work correctly. Now, the XYZ configuration 3D printers, they're pretty darn sturdy. This one's pretty sturdy, but I don't think you could do any heavy cutting with it. Now, what I would like to try eventually is taking a Dremel and cutting circuit boards with it. Because I think that, yes, it is accurate enough, and you could cut and route out the surface of a printed circuit board with this particular 3D printer. I think it would work. But you'd have to run it slow, because the more weight you add to this end effector, the more chances you have of skipping a step on your stepper motors down here, and you don't want to do that. As soon as you do that, then it throws the whole thing off. Because again,
this next one is probably going to be a stupid question for anybody who actually knows 3D printers, but for the uninitiated in the audience, what is the descriptor language that this thing wants to see that describes the object that you're going to print? I think I heard you mention something about an AutoCAD product. What software do you use to generate the descriptor file that the computer uses to create the 3D object?
I actually use Google SketchUp. It's free.
Google SketchUp, and that
it's
what file extension does that create?
Well, here's the deal. You can use any CAD drawing program, okay? All you have to do is end up with an STL file. The STL file is like a triangulation configurated file. I don't know what it stands for. And it turns everything into triangles. But basically, you take that and import it into some sort of a slicing program. There are many free slicing programs. I used K-Slicer, K-I-S-S L-I-C-E-R, I believe it's spelled. And it's free, it works well. Really quickly, I'm going to insert this marble into this object, so bear with me. There we go, it's in there. Now, I did that because I wanted the marble inside this printed object that you can't get out, just to show people, because it's fascinating. Anyway, the STL file, you import into a slicing program. Now, the printer reads a G-code file, okay? A G-code file. That is a standard machine file. A CNC machine uses G-code. It's nothing special. It's actually a machine code file. But what's special about it is the firmware that you're using for the printer. If you Google RipRap, you'll find 3D printing. That's what it started out as. The name was RipRap.
RipRap. That's R-I-P-R-A-P, right?
Sure, I really don't know, but if you Google 3D printing RipRap, I'm sure you'll find it. There's a RipRap Wikipedia page or something, and it has everything you've ever wanted to know about the coding of the language, the different firmwares that are out there. Everything is out there for you on that Wikipedia.
Yeah, I'm told it's RipRap. R-E-P.
Okay. That's good.
R-A-P.
Fix me up.
Okay. Fire Pinto has straightened me out on that. So
That's
it's
right.
R-E-P-R-A-P. If you're doing your search on this, that's the buzzword you want to search on.
Excellent. Thank you, Fire Pinto. I asked him to come and speak later and help me answer questions if his Skype is working. If it's not, no big deal. But he's got really bad internet like I used to. I actually have decent internet now. So basically the G-code is what this reads. Now, the STL file goes into this slicing program, and then you have to set every one of those parameters. So you have to tell it what type of plastic you're using, what temperature do you want the heat bed. Remind me to talk about the heat bed. What temperature do you want the extruder to be? How fast do you want each move to be? What's the top speed you want it to run? This is running at a fairly slow speed. 3D printing is pretty darn fast if you've got the right printer. I'm running slower because it's more accurate, and I don't want to tear this thing to little pieces yet. I want to build a more beefy one to do that. But basically, that you have to set all these parameters, and it took me a month to just calibrate this printer. There's some things you had to do in the firmware when you download it to the Arduino to set up this particular printer. Now, like I said, don't let this scare you, because you can purchase a 3D printer right off the shelf, and you don't have to do anything except grab 3D files, which you can find free on the internet, and hit print, basically. It's super simple for people that want to get into it.
An obvious question that I probably should have asked before, it came up a little while ago. I think Zero Fossil Fuel has asked, what size object can you comfortably print in this device? I think he's trying to figure out whether or not you can get an AR lower out of that thing.
This particular printer, I think most of them, the generic printers you see out there, maybe do 100 millimeter tall. This particular printer, I'll hold this is a 24-inch ruler. I'm going to hold a 24-inch ruler in here. I'm not hitting the top. Okay? Now, I can't print to the top, but basically right at 400 millimeters is what
Okay, so 400 millimeters tall, and
yep,
what is the bed size?
The bed is 250 by 250, but I'm currently only using like just under that. And the reason I did that is I moved just a tiny bit more room, so I made my whole entire table just a tiny bit smaller. But basically, 250 millimeter by 250 millimeter by 400 millimeter. So I can print a really, really nice big, quart jug or something, or a gallon jug or something fun like that. All
right, to answer the question that's been floating around in the chat room, yes, you could just fit an AR lower, but you'd have to print it standing up on the end. It would not print it sitting flat, so it might be a problem. Although I don't know, he seems to be able to print these Christmas tree ornaments standing up, so maybe.
I have printed. Let me show you an object. One of the uses for this could be to build something you wanted to sell. And the only reason I did this is to help me pay for this printer, actually. And they're freaking awesome. So some of you have seen this levitating device. I won't talk about it much. You can go to rwgresearch.com, look up diamagnetic levitation, and you'll know exactly what this is. But, got a magnet in there. Okay, basically I 3D printed this on my 3D printer as parts. So, let me pop this apart. I designed this to snap together. Here's one piece. Okay, I believe this is 5 millimeter wide by, maybe at the widest 15 millimeter there. And the interesting thing is I printed this standing up like this.
Okay, I think you just answered Zero's question. That has not saved your ass, but it is something that you... Zero was asking what you printed with this thing that has actually saved your ass. And so far you've not printed anything that has saved your bacon or been critical to putting a project together, but you have indeed created an object that might be a source of revenue. I mean, it's a cute little executive dust collector.
Yep. Let me show you what it does. This is going to be really bad and really hard to see. Let me get the light back there. Get the light right in there, and it's hard to see, but that magnet is floating in midair with zero electricity, and it will do that until these magnets die. This is 2 pieces of bismuth, and I'm not going to go into detail, but I just wanted to show you an object that I printed. Now, for those of you going to the Global BEM, I have literally printed off, and this is just 15 of them. Here is 15 of these levitators. You might ask how long this took. Like I said, I've been printing for a month straight. In this printer, which is a little bit slower than most, this particular piece takes 90 minutes. And it's hard to see. It's hard to see, but I've actually embroidered RWG Research right into the side of it, and it prints it just like that. So you can
so Russ,
some stupid detail.
So after Russ's show, you will have a little booth out front, and you'll be selling this interesting little executive dust collector to anybody who might be interested in one. Now, give them the bad news, Russ. How much is that puppy going to set them back?
Well, I am going to accept donations for these. and I can't have less than $50 or else I'll be losing money. I basically gain maybe 30% or less on this. That's it. The parts for this are very expensive, and I had to machine all of these pieces, and I've got a lot of time into this. So basically I'm doing this just to let people help support me if they like to donate $50. And I'm only doing that at the conference, but you can purchase them on my website. I've had them for sale for probably 5 months now. So if you'd like one, you can go there and look at the details. You can see it in more clarity. I've got some cool videos on it. But it's just a fascinating eye-opener, and that's all it is. And I told myself I would never sell anything, but this is just so freaking cool that I had to sell it. I just couldn't hold back. And I tell you what, if I didn't have the 3D printer, my first prototype was just made out of plastic, and I had to hand machine it all. And I'd never been able to sell those. My sister wanted one for months, and I never made her one. But I did once I started printing them out. Gave her one for her birthday. Anyway, and like I said, I never thought I'd sell nothing. But, you know, after I got to thinking about it, why can't I just print out the parts, make the pieces, and then let people have them? Because a lot of people can't make this stuff by themselves. Now, this is an open source project. This device you can download on my website, the files. If you had your own 3D printer, you can print it out. The dimensions for the parts are all on there, and you're on your way. So, you know, the object is for sale, but it's fully blown open source. You can go build it without me being involved whatsoever. All the stuff is there. Check my website, rwgresearch.com. Okay.
Now, another interesting question that's come up, and it's totally off the topic of 3D printing, but it came through, and I'm going to try to feed it to you. I've got at least one party out here who seems to think you might be capable of carrying the LENR banner. Have you considered starting yet another project and delving into the wild and woolly world of LENR? Or are you content to see if just maybe you can make that popper pop on command?
Well, I have a few people that are really deeply into LNER, so there may be a chance down the road, and not anytime soon, maybe a year or longer, that I might give it a shot. But right now I definitely don't have some of the things I need. But there's a few things happening. There's always stuff happening in the background. I just literally do not have enough time to share every tiny piece of information of my life with everyone every single day, so keep that in mind. There's a lot of little piddly things going on. But I'm going to give you a big no for at least a good year or more, because I got other things I want to build, do, finish, try to finish, or at least try to make more sense of. I forgot to mention something about this printer, and that is the end stops. Basically, how do you keep this thing from ramming into the ends? On this model, I created this little magnet holder. It's hard to see. And it holds a little bitty magnet. And as it goes down here to the bottom, there's a hall sensor on a little end stop. And these come in the kit. I will tell you that the kit that I purchased came off eBay, overnighted from China for $200 flat. That came with this screen, the card reader, the end stops, 2 different types, 6 total, the magnets, the Arduino, the controller, the heated bed, all the wiring, and I believe that was it. I think I bought the motors separate. Yeah, I think I did. Maybe not, but I think I bought the motors separate. But that's the cheapest I've ever found the whole kit like that. And it's, if you look up 3D printing, you'll find out it's a giant mess because there's a billion different versions, and that's what kind of Tommy was saying. It's a freaking mess. It's a nightmare for people who want to build something from scratch, and it can be, unless you focus on one type of printer and you look around, because you'll find enough information, then people will help you on the internet to get one completely built. So, on to my other project, LNER. Not yet. Let's tell you about the other project I'm working on. Here's a few more printed objects real quick. This is a gear. I went purchased gears instead of using these because I didn't like them, but it's hard to see, but this is an actual printed gear. Most people use printed gears. Pile of leftover printed parts that I was using for this printer build. But anyway, what's my next thing that I'm doing? Well, here's the deal. This filament is not very cheap. It does last a long time, but if you wanted to print out a milk jug, you're going to use a lot of plastic. This is a 2.2 pound spool, and you can find them as cheap as 15 bucks straight from China, Jeff told me. When I buy them, they're usually like $30 to $35 for a 2.2 pound spool, which actually it's a lot more plastic than you think when you're printing, because don't forget, a lot of these objects I print are hollow. Here's the inside of an object. I see the light really threw it off, but the inside of an object, and you can see I've printed this with maybe 25% infill, as they call it. The only thing that's solid is the outside. Everything else you can print completely hollow or just a tiny bit of support, because you are limited. This object right here is probably the most open object you can possibly print that I have found yet, and turns out really, really well. You just have to remember that you have to put layers on layers, so you can't lay plastic in midair. It won't work. So just something to throw out there. But you can, the software you use to slice, you can layer what they call supports, and you can choose how much support you want, and it'll automatically fill in that for support. So you can do that. It's just a little bit of cleanup afterwards. So, what's my next project? Filament. It's too expensive. Every TV, okay, that I pull off the side of the road and use the magnet wire, that TV's made out of ABS plastic. That's what I'm printing out of. So how do we get that plastic into a spool that looks like this? Because that's the most difficult part. Well, I'm already started on that adventure, and it's going to be my first project, because it won't
crunch it up into itty-bitty pieces, then you melt it into a semi-viscous fluid, and you squeeze it through an aperture.
That's correct, and that is exactly without the shredding of plastic. That's how that 3D printer works. It's nothing more than extruding a piece of plastic. Well, there's a gentleman on the internet, and there's a few of them. The one I'm going to tell you about, his name is, I'm not going to remember. Linneman. Oh, hey, printer's done. Let's do that first. Alright guys, you just watched this print. Okay, actually let me get you closer. I forgot to talk about the heated bed. I'm going to have to come back to that other. Alright, so here's what I got. Usually I let this cool down, but we'll peel it off. I laid a real thin sheet of ABS plastic on here so that I can make this plastic adhere to it. I'll explain about the heated bed really quickly.
It looks like that bed's made out of a mirror. Is that a scrap piece, or is that something you bought special?
That is a scrap piece of mirror out of a rear projection TV, because it's high precision glass, and I thought I got it laying around, I might as well use it. Again, found on the side of the road, that piece of glass. Here's your object. Hopefully this focuses, because sometimes it hates me. And it's black, it's kind of hard to see. But here's the white one. That's a pretty complex piece of plastic right there, but you just watched that print during this presentation. So that's pretty, I don't know, handy and amazing and just ridiculous. So we'll leave that here. This thing's going to cool off, and we'll move back to my
I'll tell you, you're going to have a well-decorated Christmas tree this year.
Yes, I am. Along with all my rodent coils, I'll be all set. Okay. Really quickly, because I did forget the heated bed. All right, you have to have a heated bed to print ABS plastic. ABS plastic melts at like 400. Well, I'm extruding it like 447 degrees Fahrenheit or 230 degrees Celsius. And basically, if you lay hot plastic on a cold surface, it's going to peel. Now, people will print with PLA on glass and have no problems, or they use Kapton tape, which is a high heat tape. But you can do certain plastics without a heated bed. But for ABS, if you don't, what happens, and this is going to be a good example, this is a failed print, and it's hard to see, but do you see how warped that is?
Yeah, that print job's warped.
Piece of junk. Throw that out the window. Let me
No, you're gonna chop it up into pieces and extrude it back into a plastic wire.
That's what we'll get to. Now, this is hard to see, but that's the plastic. When it cools, it sticks to the glass if it's heated, and you can actually get perfectly flat pieces, and you don't have to worry about it. If it starts peeling like this, you can throw the print out the window because it gets knocked off the glass and you're done.
Yeah.
Really quickly, I wanted to talk about something I learned that is super ridiculously needed if you print with ABS. Basically, acetone melts ABS. Got it? This stuff's pretty bad, so make sure you're in a ventilated area. I'm not going to pour it out. But what I've got here, I'll use this clear maybe. I'll use black so you can see it. What I got here is just a baby jar, food jar, full of melted ABS plastic, dissolved basically, or melted. I call it melted, but it's dissolved in this acetone. Now you can't do PLA like this. You can only do ABS. But basically, it's a nasty, nasty slurry. Okay, what I do is I get a credit card. These are blank cards, actually, and I get a little bit, and this stuff's too thick. I need to put a little more acetone in it. But basically, I get a little bit of plastic on there. This is just a scrap piece of glass, and I layer the plastic on here like this. All right, and that's a pretty crappy job there. Let me grab this other piece of glass and try it again. That's a pretty crappy job. But basically,
what the idea? Basically, what you're doing is you're preparing the bed so that your project will stick to it.
That's right, because most people use like a Kapton tape. I'll show you what that looks like. I got a piece over there, but I lay a little thin layer like that. All right, and I just usually wipe the rest of this off and wipe this card off. Close this baby back up. Baby jar. Anyway, so I just let that dry, and it takes just a few seconds. This one's probably already dry. It's slightly wet here and there.
By the way, that's how you make your ABS ready to extrude back into wire. By the way,
that's one way to do it. Yes. I'm not doing it that way, but that is one way to do it. So now I've got a place for that ABS to stick to. Now I can and have printed on glass, but only smaller objects. When you get into bigger objects, because of the heat differential and the ambient air, it'll peel on you, and it's a terrible, terrible thing, and you will fight it, in which I did. Fought it for almost 3 weeks until I saw someone else doing this. I didn't come up with that. Then when you're done with your print, that's not dry enough, you can scrape it off just like I did over there. And this will peel off of here. It's still a little wet here and there, but you get the idea. I have a thin sheet. It's basically like printing on a sheet of ABS plastic, but when you're done, you can peel it right off the glass. And the other thing is don't peel it off while it's hot. You won't be able to get it off. You'll ruin the piece. What you do is you can either, this particular bed, you can take these clips off and take the glass off. And then you can let the glass cool. But if you just let the whole thing cool, you'll over time hear it popping and cracking, and you'll hear it, and it'll come off the bed. The reason for that is because the ABS is different shrinkage than the glass is, and it'll pop off there. So keep that in mind if you're using ABS and you can't get it to stick to the bed, or you can't keep it on there and it peels up. I mean, I'll tell you what, I fought that for a while. I almost dumped this thing off the desk. It can get frustrating, but look on the internet for what other people's done. That's the best advice I can give you, because that's what I did. It's not my idea. That one isn't. All right, back to this. I don't know how much time do we got, Gary?
As much as you need.
All right, well, I won't take too much, because I want to let people ask questions. That's why I wanted to throw them up. I didn't want to miss any or forget any. So this is what I got. This is actually on right now. This is 120 volts AC I'm using, so it's kind of dangerous. What I got here is a temperature controller. Ooh, that looks pretty on this refresh rate.
Man, 120 volts won't even curl your hair.
Well, let's just say it'll
just let you know it's there.
It'll make your balls shrivel up. Okay. Anyway,
it'll do that.
Back to the project, Gary.
What'd you say?
You heard me. All right. So here's the deal. I would like to use scrap plastic that you can find on the side of the road and turn it into filament. This is the filament. Again, it's 1.5 millimeter ABS plastic. You can find almost every object laying around is made out of ABS. Most things are made out of ABS, and then you've got PP, polypropylene, and a few other plastics that are very, very common. But ABS is the one that you can print with. It does work, and you can recycle it. So how do you get from a full-blown TV housing to a piece of extruded filament that you can use? Well, you do have to shred it, and I'm working on that device. Currently digging parts out of my random junk that I have to make a shredder. But right now what you see in front of you is part of the extruder that I'm using to extrude the chopped up pieces of plastic and extruding them out. Now again, I'm not the original person to think this up. That's why I love open source. It's all about sharing and building, and you can replicate, and it's fantastic. So basically, I have a temperature controller. I have a digital relay, or a I forgot. It's an electronic relay. And then I have here, this is actually just nothing more than a resistor. I'm testing this idea, and I've seen people kind of use it. This is a 33 ohm, 350 watt resistor. It pulls about 3 amps at 120 volts. Enough to make my lights ever so flicker because I'm pulling enough power from my basement. I don't have the greatest service. So I'm going to use this resistor, which I had laying around, to actually heat up the plastic and extrude it. Now, how do you get from pellets to extrusion? Well, the individual that's doing this online, and I cannot remember his name, Fleeman or something like that, you can Google it. Look up 3D printer extruder and you'll find it. This is just nothing more than a wood auger bit, a Bosch wood auger bit. It looks like an auger, acts like an auger. It removes the chips.
I'm already starting to see how this is going to go together.
Uh-huh. Now, I've already ground the end off this. It's had a sharp tip on it. Awesome.
Man, you had to do some serious grinding because that thing's made out of some high-carbon steel.
I got lucky. I have access to a plasma cutter.
Cool.
I whacked it right off. It was pretty clean. I was kind of afraid of doing it, but after I cut it, yeah, a little bit of grinding and it was done. So I was kind of, I was wondering the same way, Gary. How am I going to make this work? But plasma cutter, it took care of it.
Plasma cutter made easy work of it.
Yeah, I'd like to own one of them eventually. I've got some pieces and parts that see, there's the other thing. I got projects that I've got parts in boxes laying around that I want to get to. So
now you might have been surprised how good an HHO torch would have worked on that, but that's okay. A plasma cutter works too.
Yeah, it could have. So basically, this is the auger portion of this extruder. And a regular extruder has an auger that has a shape to it where it gets compression, and the compression heats the plastic. Well, this is a straight auger. I was going to make one of them, but I didn't have a lathe that I had access to that could cut the right threads per inch. So I decided to go with the idea that other people have been using because it works. I've seen them do it. So I've got a piece of stainless steel pipe right here, and I did have access to a bore, and I bored the inside of this out. It's hard to see, but it's a pretty nice bore, and it has a pretty tight tolerance. Okay, now this isn't done. This piece goes in this section. I'll be cutting this out so you'll have access from the top to the auger, and that's where your hopper goes. So you put plastic in this hopper, it goes down and it gets fed into this auger. As this auger is spinning, on the other end of the auger, I'm going to have a bushing here. And these are all ideals that I have right now. Some of these things could change, but I'm pretty sure this is how this is going to go together. I'm going to put a bushing here, a heat bushing, and weld flanges on the end of this pipe. The other end of this will have a little motor. This will turn maybe 1 or 2 RPM, very slow. If I get the plastic hot enough, I could go faster. But most people have been using between 1 and like 3 RPM for this setup.
Now, how hot do you get ABS before it starts to smoke and becomes no good?
Well, my printer uses 230 degrees Celsius,
so,
which is like
450 degrees thereabouts.
Right at 450.
So
but
you got to control. I assume you got to control your temperature because if all of a sudden you hit this ABS with 1,000 degrees, this stuff would just burn off.
Right. It's hard to see, but this temperature controller is on and it's sitting at 420. I've been doing testing with this all day.
I see. So you control the temperature, and and all that does is trigger the relay that activates your heater.
That's right. I don't know if you can see that little green flashing light on the side.
I can. It's 420-ish, it looks like.
Well, no, on the side here.
I can't see the red one. I can see the green one.
See the little bitty green light by my index finger?
Yeah. I see the little green light.
That little green light's showing me the output of this relay turning on and off. Okay. Now, what it's doing is these controllers are designed for this. They have PID loops in them, and you can... I actually auto-tuned this. It's pretty sweet. This is actually something I got in college that they were going to set on the buy-buy shelf, and I've had this sitting around for, 8 years, 6 years, whatever it's been. At least 7 years for sure. They were going to dump it, and I didn't know what it was for a while. And after I got to thinking about it, I'm like, I got one of them laying around. I've actually got another one here, another scrap item. I've got one more of these controllers. I may make this a dual heated zone, but so far this resistor is working. But basically, that's the temperature controller, Gary, to answer your question. It does have a thermocouple on it. It's a regular J thermocouple, nothing fancy, standard industrial stuff. Yep, that's it. So back to the extruder. This is a screw, and if I hold these pieces just right, you can see how the plastic will fall in those grooves and get sucked down the tube. Okay. Now again, I have to notch this piece out here. But the plastic will get extruded or pushed in pellets or chunks or shredded or whatever you end up with, and it will push the plastic through this pipe. Now currently, that's how it gets into the pipe. Currently, I have a piece of stainless here. This is actually just regular 3/4 inch, no, 1/2 inch stainless steel like water pipe. This piece of pipe is just a regular piece of pipe I bought for some of the Stanley Mayer projects. Little piece that I had left over, and I'll probably end up using it because this is too big to fit inside my resistor. This actually fits tightly. I can't even push it through. I'm going to have to take some emery cloth, cut it off there. But here's the thing, I'm using a power resistor as a heating element, and some of you are going to freak out, but I'll be honest, I did some research and I didn't realize this, but all the new 3D printed print heads, or not 3D printed, but the 3D print heads are using power resistors. They're just 5 watt or 3 watt or 10 watt or whatever you're using. And it works really well. I did not know that. I looked up on the internet, use your resources, guys, that, okay, I want to use a power resistor. Is that going to work? And I found out that DigiKey has some information on their website about using power resistors as heating elements. It's actually a common practice. I didn't know that. So I thought, all right, I'll grab a 350 watt power resistor, and we'll see if we can get that sucker up to 450 degrees. And it's sitting at 420. I can go up higher, and I have, but that's between 350 and 400 is probably what I'll be using when I'm done. Now this resistor looks like it's getting a little, I don't know, like it could get brittle after some time, or at least the coating is brittle. But here's the thing, it's either this, buy nickel chromium wire, or get a resistor that's nickel chromium wire. Why not just get the resistor? This is actually nickel chromium wire, which is what I'm going to be purchasing or needing to get. So again, using my resources, I'm going to try this method. The other people I've seen out there are just using like a heating band, which you can buy, but I'm keeping this cheap and free. Using my resources by using this power resistor. So the plastic, this pipe will be actually welded on the end of this pipe. Alright, and I'll be pushing not melted plastic into a heated melted plastic area. I'm going to show you. I have a piece of filament here. I'm just going to stick this inside this pipe. Now watch, it doesn't take long, and there's a lot of air in there, so it takes a fraction longer. But if I pull this back out, this is now, leave it back in there a little bit longer. Basically, it'll melt this plastic inside this pipe to a temperature where it doesn't burn it. It just turns it into, there you go. It just turns it into, it already cooled. It cooled that fast. It's already hard again. It's because it's so thin. So basically, the plastic will get hot to the temperature that it is viscosity of whatever, however viscosity, I don't know how you say that. However,
viscosity.
Yeah, however viscid, I don't know how you pronounce it, but however much I wanted. And you can see that that's about the right temperature there. See how pliable that is? If I let that cool off, it's stiff again. So I know my temperature is pretty close. I'll have to play with all those parameters to make it correct. But on the end, I'll have nothing more than what looks like the printer head. And it'll have a number, say 0.631 or something like that, is what the individual was using online. That seemed to be pretty close. And after it cooled, it was right at the 1.5 millimeters that we're looking for, 1.75 millimeters that we're looking for. So I'm going to actually be able to extrude my own plastic, because here's the thing. This plastic, for me, let's see if we can do this. The plastic, for me, is too expensive just to print milk jugs off and vases and cups and bowls and just have fun with the printer. I can't have fun with it because I'm not going to spend the money on this plastic. It's too expensive. So if you're selling your items that you're making or whatever, then fine. But for me, it's not worth it to buy that much plastic and just waste it, basically. So I thought, how can I fix that? And I got to looking, and people are doing this online. They're extruding their own plastic filament, and they're using it. So I thought, I probably got enough junk laying around. Could probably do that for next to nothing. I spent $8 on this auger bit. That's it, $8 on eBay. That's probably the only item that I'm going to need to buy. The only thing I'm going to need to buy is a bearing. I need to get a compression bearing or a linear force bearing, whatever you call them. Can't think of the name. I'm going to need a bearing. Yeah, well, a linear force bearing, whatever you call them. But I'm going to need to get a bearing because I have a bunch of crap, but I don't have that size, and I don't have I forgot what it's called. A bearing that you can do linear, do side forces on. I forgot. Anyway, that's the only other object I think I'm going to need to purchase is that bearing. You can 3D print plastic gears, and you can 3D print plastic chain, and you can, or you can use bicycle parts or whatever, but I'm not sure quite yet what I'm going to use. I have enough stuff. I would take you for a short tour. I'll give you the quick rundown. I don't know if you can see all the parts I have separated.
I can tell you, Russ, that you're one of the few people you're one of the few people I know who has a larger junk pile than I do.
Junk? What are you talking about? Junk? This is useful resources, but yeah, I do have.
When my wife wants her laundry room back, I usually have to lose about 2 tons.
Yeah, well, my wife's not real happy, but I gave her the other side of the house. It's just when I destroy upstairs, I never hear the end of that one. But yeah, I've spent last summer building this 3D printer. Winter, building this 3D printer and organizing my basement. I don't know if you can see in the very back, but I've got totes back there, and I got these totes for next to nothing. Otherwise, I would have never organized this, because I used to have it in cardboard boxes, and that was a joke. I'll never do that again. But anyway, yeah, I probably got enough stuff to actually finish this extruder and make my own 3D filament. Now, how am I going to shred plastic? Well, if you look up a granulator, it's basically a 3-bladed device. Most of them have 3 blades, and it's just a shear point. So it's a triangulated thing like this on a shaft with sharp blades. I have access to high-speed steel pieces that I can use. They're scrap, so I can use those as blade shear points. And basically, as the blade comes around, it hits an anvil-type blade as a rotating blade comes around, and then there's a grate at the bottom. So as the plastic gets sheared off, thrown everywhere, it's probably louder than it can get, that plastic will be chopped up until the point where you have a screen and you have holes in that screen, and whatever fits through the screen will fall out. The rest of it just keeps getting picked up and thrown around, and it's probably really loud. And I've got enough stuff, again, to build a device like that. It's going to take me a little time. I actually took apart an old treadmill. Let me get this camera off here. I built this. This is probably one of the first boxes I ever built. What this is it's an old treadmill. And I took the treadmill apart and I made a wood box. That's the first project box I probably really truly finished and made, probably about 15 years ago or so. I mean, it was the first thing I ever really finished in a nice box. Basically, I can run a treadmill motor. Those things run at like 7,800 RPM at 190 volts DC, and it's just a DC controller. And they're like a 3/4 horse or half horse motor. So I'm hoping if I can get that granulator rotor up to, I don't know, let's just say 5,000 RPM, easy probably. Throw enough plastic in there to at least let the momentum or the amount of weight that I'm going to have on a flywheel to just eat that plastic up, and then if I got to keep going with it, or I don't know if I'm going to have enough torque to do it like at a slower pace, so I'm thinking a higher RPM. Yeah, I'm going to do that one out in the garage with the garage door shut. Anyway.
I bet you. wait until the wife and kids have gone out somewhere.
Yeah.
What about a heavy duty commercial shredder? Do you think a heavy duty commercial shredder might work for this application? The problem, of course, is that a heavy duty commercial shredder, you're talking $700-800.
Yeah, well, for $700-800 on eBay or Craigslist, you could probably find a granulator that's old and rusty that you could fix up. I haven't looked, but I've seen a few online, the regular just granulators that I'm going to build for $3,000 to $4,000, but they're in like really good shape. You could probably find one for cheaper, but I probably won't. I'll probably just build one because that's what I do. I like using my resources and building it for nothing. Showing people that you can build stuff for nothing. Just look around. But But yeah, a paper shredder type of paper, or like shredder. I've seen people try it, and for what I'm wanting to do, I'm wanting to take like a half of a TV housing and just chuck it in this thing, and end up with little pellets. So if you took a pair of shears and you cut all these pieces up and then tried to stick them through one of those, maybe, but I haven't seen anybody out there that's been able to successfully do that. I've seen people try it, but nah, I'd say that's the wrong type of shredder. I have seen shredders that have the real slow-moving claws that just grab it and shred it, but again, you're going to have some access to some pretty high CNC machinery and some pretty high-grade tool steel or something to make that out of, and just don't have access to that kind of stuff. So I'm probably going to make I call it a slap chopper. I don't know what it's truly called, a granulator, but I'm going to call mine a slap chopper. And it's going to be loud, noisy, but it's going to do the job, and hopefully get my pellets out of a old recycled TV. Kapton tape. I told you I'd show you what it looks like. This is Kapton tape.
Now, is that metallic?
Yeah, it's kind of metallic. I didn't realize what it was. It was made by NASA or something stupid. It's kind of clear yellow, and basically I can wrap this tape around this hot. I wrap it around my hot end. That's what people use it for, is really hot applications. This stuff just sticks. I don't understand how. I've never seen this stuff before. I don't know the temperature ranges, but it's ridiculously high. They use it on like the space shuttle and stuff like that. So Kapton tape. I don't know how to spell it. It's not super expensive, but this is the only roll I've ever had and the only roll I've ever bought. But a lot of people are using Kapton tape on their glass bed or whatever to make the plastic stick to it. Well, then you can't get it off. It's a huge pain in the butt. So the liquid ABS layer of plastic is your best choice if you're using ABS. I would like to open up for questions.
Well, I'll tell you what. But before we turn it over to the audience for questions, I've got a couple. All right. First of all, what's happening with the popper? Has there been any progress at all since last time we talked?
Not a whole lot. Maybe since me and you talked, probably. I do have a gentleman by the name of Tim Alls has offered designing a what's the company called? The National Instruments LabVIEW piece of software that we can use with the PLC hardware that he's donated and actually control the popper with precision and then accurately read data from it. The problem is because of the nasty RF, the high voltage, the very odd things that happen, I'm almost afraid to hook all the testing equipment to it, because as soon as I do, it goes poof, and then we got nothing again. So I've got to be very, very, very cautious on how I connect the test points to the popper device, and I've been pondering ideas on how to do that. But with the pulse motor build-off, the conference, and life going on, I haven't been focusing on that directly. I am going to winterize my garage or install a. I got an old heater out there, like a regular heater you'd have in your house, and I can convert it to LP for relatively cheap. So before winter hits, I'm going to do that so I can work in my garage this winter, so I don't have to worry about winter, because I'm out in the cold all day at work, and I really don't want to be out all day at home working on these projects and losing more and more sleep, because that's going to drain my bones. And some of you have noticed that for like 2 years straight, 2.5 years, 3 years straight, I just produced a video like every day that was super detailed. Well, that burned me out. Let me tell you, it did. It burned me out. And so a lot of people think I gave up on some of these projects. No, I'm burned out. I need a little break. So I've been taking it easy, taking it a little slower, making sure I don't burn myself out, because you can do it.
It's called pacing yourself.
And I need to learn to pace myself a little bit more.
I got to ask you. I've heard your disclaimer, and I understand, believe me, but I got to ask you, because there's going to be people that are going to ask me, what about all the Stan Myers stuff you're working on? Have you kind of put that aside as well? I mean, is it still on the agenda, or is it something that you've put aside for the time being?
Nope, I'm going to hold Art in Vegas to his word. He's supposed to send me a piece of micar, which is the plastic that goes in this injector, okay? I still haven't purchased the micar because he offered to send me some. So I just talked to him earlier this week. He's supposed to send me the micar machinable ceramic, and I'm going to send this injector back to the man who originally machined this. He wanted to help, so he offered to machine it, so he has. His name is Scott. He's a ridiculously fantastic machinist. Like, I'm anal about not having something right. This guy must be way over that because his stuff is so precise and just.
You're saying he is so anal retentive, only dogs can hear him fart.
More than that. Like, it's crazy.
Only chipmunks can hear him fart. Okay, we got it.
Yeah. But I did 3D print a test piece so that we could at least try. This is actually 3D printed, and that is an application that I used this on. And it'll probably melt right away, so I haven't actually used it. But the idea was the fact that I can, and maybe use it for one test. But I've been waiting for the My Car so I can send that to him to finish it. I do have all of the other Stan Mayer stuff over here. Now that I have the data logger, what I'd like to do is get the EPG out and test it. See, most people don't understand this, and I'm glad that you asked me this. I have not tested the EPG for one reason. I want to make sure I'm doing it accurately, and I do not think I have the data and information that I need to do the test accurately. So to make some sort of a magnetizable gas takes a certain process, and the reason I went to the popper is because, one, I had people that were wanting to help me, so I let them help me, and two, because I need to take a break from Stan Meyer and get my head wrapped around how can I take and make this gas. Well, the way I can do that is by working on another project that has to do with the same type of things, and the PAP replication is exactly that. Believe it or not, I could not figure out how to get a high voltage arc to discharge across an air gap and hold it there, because that's how I want to vaporize the iron or nickel or cobalt. But after working on the PAP project, the idea just hit me. It came to me, and there it was. The whole entire apparatus I need to make this gas is there, and I wouldn't have been able to come up with that idea if I didn't work on the PAP project. So I'm glad you asked me that, because I want to explain to people, no, I haven't given up on those things. It's just a matter of I need a little time, a little break. And if you ask anyone that's working on this type of research, they will tell you that if you jump around on projects, you have to take a break from projects and work on something else, because you'll come up with the answer for that project on a different idea that you're working on. That's how it works.
All righty, well now let's settle in and let's address the audience. Now, fellas, I managed to extract some of your questions out of chat, and we posted those up to Russ as we were moving along. But I'm sure that a lot of good questions flew through the chat room that I missed because I was busy talking to Russ, and frankly, it's I'm getting kind of old. My eyes are kind of bleary, and it's hard for me to do two things at once. I can't walk and chew bubble gum at the same time anymore. In any case, if anybody out there in the live chat audience might have a good question for Russ, I'll try to direct those to him right now. Let's see here. I'm looking. I don't know. Yeah, you play the music in the background. I'll wait for the good questions.
Well, I'm glad I got some of the other questions answered, because that's what I wanted to do. I didn't want to miss any questions or forget them, and I knew I had a little more time than usual, so I like to be able to explain things well enough for people to have their questions answered. I do apologize real quick. I do apologize for people who have emailed me and I haven't responded.
Just freeze ABS, it shatters easily. That's interesting.
Say that again?
Just freeze ABS, it shatters easily.
Depends on how cold it is.
I got one out here asking your autograph. You're going to have to go to the show to get his autograph. Bring a T-shirt and a Sharpie, and he'll sign it for you.
There you go.
Let's see. Excellent presentation. I know what SSC is going to give at this pace. Dead tired. Yeah, I'm tired. Let's see. Fantastic work. Will he try printing with multiple materials on the same job? Are you talking about printing in
Probably not.
It's tough to do because he's only got the one print head. So once he starts with a spool of material, it's pretty hard to stop in mid-project and change material. So I don't know.
The question on another answer that he may be looking for is, when I get this extruder done, I have a friend that has access to different types of plastic, and I can get my hands on small samples of different type of plastics, and I will be trying to extrude and make filament of polypropylene for sure, because that'd be a fun one to build stuff with. And then all the different variations of plastic that he can get a hold of, if I can find enough information, I will be making filament and trying it. That's something I want to do because a lot of people out there are trying different plastics, but nobody has their own extruder and are willing to like put forth all the effort to try it. So I definitely do want to try different plastics, if that answers your question.
I got kind of a strangely worded question from one of the anonymous users here, but I think what they're asking is, what's the method to your madness, Russ? Why are you working on this stuff? What is your motivation?
Two reasons. One, after you do it for yourself, you'll be fascinated to the point where you'll want to do what I'm doing. And two, it's all full-blown open source, and that's what I'm about. I'm about open source. So sharing information, helping people out learn that you can print with different plastics, makes the 3D printer more valuable for printing with other plastics if you can build things. Because right now it's ABS and PLA and a few specialty plastics like nylon, I believe. You can get filament for, but it's really expensive. So if you can get to the point where you can make it yourself, you know, it's awesome. But I mean, I'm doing this because Fire Pinto and Jeff held my feet to the fire, and now I'm super excited about it. It's a fascinating thing that you can do at your home. Think about it. Draw something up.
I got somebody out here saying that you need to try printing with polycarbonate. A couple of them are just bragging on polycarbonate. They say that's interesting stuff to work with. I wouldn't know. I'm
not sure about polycarbonate. I know I can get a hold of polynylon. I believe it is. It's some interesting plastic
material and bake it like clay.
Here's the thing. There are printers out there right now in the exact same configuration of this Delta 3D printer that are printing clay and then firing the clay. I've seen them do it. I'm not quite sure how the extruder portion of that works, but yeah, I've seen people use clay and then fire their object, so printing out a vase. I mean, that probably looks fantastic after you fire it. Now, the thing is 3D printing isn't necessarily new, but desktop 3D printing is only maybe 3 or 4 years old, where everybody just has a printer, like paper printer. Well, now it's getting to the point where just about a lot of people have a 3D printer sitting on their desk, and that's because a lot of people sell kits completely fully done, and you can just hit print and go with it. But I've seen industrial printers that can print metals, they can print plastics of types that we don't have access to, ceramic. There's an endless possibility with a commercial 3D printer. But for the home 3D printer, I have seen ceramic being printed on the internet, and a few other various.
I got one
things,
person here saying why not print with super glue? But one of the things I was going to suggest is that if your heating element thing extruder for making your plastic wire fails, you might want to try one of those hot melt glue gun gizmos and see if maybe the heating element and tip in that might not extrude it. But that's for another day. You got your plan, and I want you to work your plan.
No, I'm open for ideas, and that's just it. Like the idea what I have here is I want to heat up.
I was thinking, one of those hot melt glue guns spits out a bead that's just about the right size. If you get it into there. Right. It just might.
I might have to look.
It just might work. I don't know.
I'll look. I'll look at the dimensions on those because that's very true. And again, use your resources. How many hot glue guns you got laying around? You might have a couple. Destroy one and turn it into a useful project.
Have you? Are you aware of anybody who has built a home printer, or basically a desktop printer that prints in metals? That question has come up in the chat room.
I personally have not looked into that question, so I can't say no. But I don't think so, and the reason is because I know people are trying to like work on it, like taking a wire-fed welder and like turning that into a 3D printer jig and trying to print like that, like with welding with a wire welder. But I don't think so, and the reason is the industrial 3D printing of metals is actually some chemical that they layer on top of that, and then when they're done, they put it in another liquid which soaks up into the 3D print, and then they take that out of the block of soft material and they fire it in like a kiln and they harden it. Somehow it turns from different chemicals into a metal. It's really a complicated process for a home 3D printing job. But I can't say no because I'm not for sure, but I highly doubt that has been accomplished.
Well, let's see here. Got Gary Langwell's asking if with the Arduino controller, if you get halfway into a job and you get bored and you turn it off, can you come back and pick up where you left off?
You can stop and pause prints with the particular firmware that I'm using. I have stopped a print and started again, and it worked. But the thing is when you hit pause or stop, when you hit stop it quits, but when you hit pause, you can actually move the head around, and you'd have to put it back in the exact same spot. And if you don't, the stepper motors don't have feedback cables on them, so they don't have feedback signals. They're just dummy servos. They just go where you tell them to go. The stepper motors do. So it's not quite what you think it is. You can't. Now here's the other thing. I've had a print fail halfway through. So what I did is I took the print that I had so far that was good, and I went back to the drawing of the sketch, and I sliced the drawing in half to where it stopped printing and started printing again, and then just glued those two halves together. That worked actually pretty well. So if you have an accident and you want to stop something, you could go back and slice the object in half and then start printing the other half of the object when you feel like it. So yeah, I guess you could. A little more complicated than you want to do, but sure.
All right. Well, I'll tell you, I think that I'm going to give the audience now. If you had a good question that I did not see, you might want to post it up one more time. Keep in mind, the chat moves pretty darn fast sometimes, and it's hard for me to keep up with it. So if you had a really, really killer question, I got time for maybe one or two more good ones before I'm going to cut Russ loose and let him have the rest of the evening to himself. Let's see here. I was thinking of inserting parts as it was printing. Well, now you did see him insert the ball into his Christmas ornament that he was printing, right? So I'm not. I hope we've addressed your issue.
I think what he might be saying is, can you actually like lay an object into a print as you're printing? And basically what he's saying is, could I take like a nut and impregnate it within the print? And here's what I do. I actually print the object to where I can press fit a nut or bolt into it, which is exactly what I've done on the little kits that I have here. I engineered this. All right, I'm going to take this apart for you. I engineered this to actually have little bitty tabs that snap together. This plastic is a lot stronger than you think it is. And actually, I'll show you. So here is one of the pieces, and you can see that all I've done is printed this out to the exact dimensions and then press fit a nut into it. So in theory, that's one way to kind of impregnate an object into your print, but in completely encapsulating an object as you're printing would almost be not doable, because you're printing from layer to layer to layer to layer, and so your print head will hit the object you're trying to impregnate. That's kind of your limitation for what you're doing. So you have to remember you're building from ground up, and the print head will go the entire surface. So,
and one question that did come through the chat, and I've anticipated that the answer is no. Your print head will not print sideways, so you can't come at something from the side and print.
Not this one, and I've never seen 3D printing from that like angle, but I have seen 3D printing from like the bottom. What it is this is the best way to do 3D printing, but it's very expensive and not very many people are doing it yet. And it is like a home style printer, not really just an industrial version, but it's a liquid bath of some chemical, and the print bed is upside down, and there's a laser that penetrates the material and hardens it, and it zaps a laser layer by layer, and then as your 3D print gets like this, that laser is putting layer on layer in this direction, and when your print done, it's like this, and the bed is upside down. And what happens is you don't have to worry about infilling anything. It can be completely hollow object because of the direction of your print. If you're printing stuff in a vertical direction, you can't just lay plastic out here. It won't work. But by going upside down, as long as it's attached to the main frame, you could layer the plastic out here. You know what I'm saying?
Yeah.
So that type of 3D printing is very new. But the individual who designed that said, I want a very high quality, precise 3D printer, and he built that, probably using resources of open source out there right now. So pretty fascinating 3D printer, but not very many people are using it because the polymer that they use is probably pretty expensive, and using a laser, you got to know how to set all that stuff up. So I don't know how it works, except for the laser hardens the material and it
Well, I tell you, I've got to apologize to the guys in chat, but I tell you, my eyes are just not cooperating with me tonight. I've had trouble with the studio lights all day, and it's getting almost impossible for me to see the chat.
Oh.
Man, you just had a train go by, or is that your phone ringing?
I got to give Gregor Ontario. He could just call me. So I got shout out to Gregor. He's in Boulder, Colorado right now, believe it or not. And he posted a video of the flood. It was pretty ridiculous when it was starting. So
I'll tell you, Russ. But before I shut this puppy down and let you have the rest of your evening for your wife and children, which I'm sure do require a certain amount of attention from you, I will give you full screen and let you make any parting remarks that you might like to leave the audience with. It was a hell of a presentation. Now, first of all, my thanks for coming on the Scarecrow Show and doing this presentation for us. It was really a very interesting presentation. Really do appreciate it. But at this point, sir, any closing remarks that you might have? And, don't forget to pitch Global BEM. I mean, you're going to be a speaker there, so don't forget to give them a pitch.
Yes, Global BEM will still be happening. I have confirmation that it will still be happening because I was wondering myself. And the thing about Global BEM is the fact that there are like physicists and high-end people there, along with, I'm throwing Zero under the bus with me, people like Zero and Randy Powell and Daniel Nuez and all the people that are just like me working in a garage just trying to do something good. And those kind of people are going to be there in the same conference. It's going to be a very interesting communication link between these people that are in books versus people who are kind of far out there, okay? So the idea behind what they're doing and inviting people such as myself there to speak on open source, which is what I'm speaking on, the open source idea, the platform that I'm using to broadcast the 3D printer, the path replication, the things that are out there right now, because if you think about it, without the open source platform, well, you guys wouldn't be doing this right now. You wouldn't know anything about it. And so that's why I like doing what I'm doing. So Global BEM, you must do that. The other last parting words is you guys really do support me, and I greatly appreciate that. I know there's some dead time, and sometimes I say I'm going to do something, and 80% of the time I do it, and the other 20% I just get caught up in life, and I can't catch up, or something happens. You know, that's life. You guys know how it is. So just keep in mind that the support that you guys give me allows me to come on here and give you a presentation and show you more information that you didn't know before you watched this. So I just want to say thank you guys. I love you all. I really appreciate the support that you give me. And, if I let you down, shoot me an email, let me know I let you down, and I'll explain what happened or why. Because stuff happens. You guys know it does. But the projects, my past projects, still on my list. Not that I have given up on any of the past projects that I've done. I actually... let me grab this coil. Hey, honey, go get that coil right there. My wife is waiting for me. Isn't that nice of her? Not the little white one. No, over there on the box. There.
By the way, thank your wife on my behalf for being kind enough to share you with us tonight. I know it was an imposition, and I do appreciate it.
Yes, I will let her know. They said thank you for letting them share me. Wasn't that nice? I started with rodent coils. I haven't presented a video yet, but this is a type of rodent coil that I've been working on. I used the 3D printer to print this. Okay, so a lot of people think, that I haven't gotten back to other projects. Well, it's because I don't have the proper resources to continue certain projects, or I'm burned out and I need a little break, and by doing something else, I gain the knowledge and experience to come back to those projects. Like the EPG, I now have a data logger, a real National Instruments data logger that I can attempt to try to make sure that thing does or doesn't work with accuracy and not just guessing. It's a waste of my time to guess through things. I want to be able to do it in a nice manner. So rodent coils, something I've been playing with in the background. I do this stuff. I am non-stop doing stuff, and it's crazy. I can't stop. Just go, 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 go. And I like building and doing stuff, but sometimes you need a break. So just remember that, guys. I just really want to make sure everybody out there knows that I don't just completely give up on things, but I do need a break, just like I'm sure most of you do. So thanks for your support. Thanks for coming out here and supporting me tonight, and hopefully you learned something. if you have more information that you'd like to know about 3D printing, you can Google it. Just Google 3D printing. There's hundreds and thousands of people out there doing it. But
if I understand correctly, there are actually forums that are devoted to this technology, and a lot of the hobbyists that are playing with it get their start on some of the forums that kind of specialize in this particular project.
Yep, I posted that video of me building this 3D printer. It's about an hour and 10 minutes long. It's got the complete building process if you'd like to see it. It's on my website under the Projects tab, 3D Delta Printer. Okay, just look on there, and there's a long video, and it'll do the software if you want to look at how the software works on this thing. But basically, I was also going to tell you my forum as well. That's open-source-energy.org. Also has a section for 3D printing. There's a guy by the name of Jeff over there, and he's very knowledgeable on this stuff. He will be glad to answer your questions and help you along your way, because honestly, Jeff didn't know a whole lot about this Delta configurated 3D printer, but he helped me enough to show me doors to places where other forums would help me. And again, that's what it's about. It's helping people, and the open source community is the only way to truly share complete knowledge across the board. So that's all I got to say, Gary. I just want to say thanks. I really appreciate the show you put on. I know, just like you get a little burned out, and it's a lot of work. So I greatly appreciate
every
what
week,
you do.
man. I'm into 5 years now.
That's a lot.
5 years of doing this program.
Yep. Well, I'm glad you do it.
Oh,
you share a lot of good knowledge.
Hey, we have a lot. We have a lot of great presentations. And I'll tell you, I go back and I look at my archive of my shows, and I got my share of stinkers out there, but most of them are really good stuff. And the hobbyists are just absolutely shocking, some of the interesting stuff that they come up with. Russ Gries, thank you so much for doing the Smart Scarecrow show. Good luck with your presentation in Colorado. I know you will wow the audience, and you'll come back feeling like you accomplished something. And please don't be a stranger. Anytime you got something you want to show off, shoot me an email, man. We'll get a date. Yep.
I will, and I keep you in mind, and I like for people just to wait until that point where I just kind of show up versus coming on here every other week like Zero or something like that. But anyway,
now. Zero helps me out. When I don't have anybody else who'll come on, Zero will come in and invent a show to keep the people entertained. Go. So, don't knock Zero on that one. He helps me out.
Yeah, he does a good job of that. I usually am not around to watch the show. I'm usually working nights.
Well,
somehow
one thing I am going to hold your feet to the fire about is, after this global BEM, I'm going to try to get guys to come in and give us a lessons learned. I've already nudged Maury King. I'm going to try to get him to come in and give us a quick presentation on what he thought of the event. So you just make sure you put somewhere on your schedule a booking for me sometime, either late in October or early in November, where we can get you in here to give you Russ Gries's lessons learned from Global BEM. I think a few presentations of that type would be very interesting to the audience. Hell, I might even get 2 or 3 of you together in a round table. We'll just have to see how it goes.
That would probably be a wise choice, because then we can all help.
I know there's a lot of guys who would love to go see the show, and for whatever reason they can't. So we're kind of counting on guys like you and guys like Maury King, guys like Zero, to come in and give us a taste, give us a little taste of what they saw there. I think a lot of people would appreciate that.
I do think that, Gary, and I will set some time aside for that. I also would like to tell you, I will be bringing my camera, and you know what I do best, so I hope to have as much footage as possible from at least the outside. Inside the conference, but not directly with the speakers, but in the lobby and speaking with people and stuff like that. I'd like to come back with that kind of videotape footage for you guys, because that's the other thing. Like, the idea behind what they're doing is bringing these people together to share a new, open the technology, open the doors, and get the information out there. But then when you set up a fee like $60 a day, they only have to do that because you have to afford to get people to the conference and make that happen. And that's unfortunate that you can't just directly shoot stuff out there, because you've got to pay for the conference. You've got to make it balance somehow. That's with anything you do.
It ain't cheap putting one of these shows together, believe me, I know.
Yeah. But you can look forward to probably see right now if you go to Global BEM, I think it's Global BEM is their YouTube. They're actually publishing all of last year's presentations on there one at a time leading up to this conference, and they'll probably do the same. For next year, they'll be publishing all the conference stuff from this year.
Well, I think it's a great marketing plan. You know, it's a little bit of a tease. You know, hey, come to the show this year. This is what we showed off last year. You know, come on down.
So they are, but they are sharing the knowledge. And again, they're doing this, voluntarily, and they're not making money from it. They're just trying to do a good thing. So props to these guys, and I appreciate the privilege to be there and share this information with everybody that I've learned in this crazy adventure with you, Gary,
and all the rest of us nuts.
All the rest of us.
All right. Well, I'm gonna cut you loose, Russ. You have a good evening. Good night, sir.
All right. Thanks, guys. See ya.
All righty, and that was our feature presentation tonight with Russ Gries. I hope you all enjoyed that. I always like having Russ on. He's a hell of a presenter, and frankly, any of you who might be near the Boulder, Colorado area, or prepared to travel to the Boulder, Colorado area, along about the 10th of October or so, you can get the particulars from globalbem.com. It should be a pretty darn good show. As a matter of fact, I suspect this will be the highlight of alternative energy shows this year. So it's certainly worth going if you can spring for it. But I'll tell you, that's going to have to be it for the Smart Scarecrow Show for this Thursday, September 19th, 2013. It has been a long presentation. I notice, we did lose a few from the audience because we ran long, and I can't say as I blame them. It was a good presentation. Russ was showing us some very interesting stuff, but hey, life goes on, and a couple of people had to bail on us, and I understand that. What? No rant? I tell you, I do owe you guys a news rant for this week. For anybody who's, I tried to do my news rant on Monday, but to be honest with you, I was too darned exhausted. I had to work a long day, and let's just beat. Tuesday night, I did do a cameo appearance with Charlie McGrath on his radio program. I don't know if I'm going to be able to get a news rant out there this week or not. I would love to do it, but to be honest with you, I'm running out of time to get one out there this week. You might have to be satisfied with the cameo appearance that I did with Charlie McGrath, and I'll try to get one together for you on Monday. It's just been as Russ was saying, life sometimes gets in the way of some of the things we would like to do. But before I bag it for tonight, I will do my best to address any questions or comments that the audience might wish to direct at me. I am having a very difficult time seeing the chat room. The text is very, very small, and it's my eyes tonight just are not working right. I'm not sure what's going on here. Let's see. Checking. Okay, Shubas is going to let me off the hook. He's going to give me until next week to come up with a news rant. I appreciate that, Shubas. Let's see here. To make my rants live. Well, see, I don't know about that, because the nice thing about doing them as a podcast is I can kind of time shift them. I can do them when I have the time. It would be difficult for me to set up a preset schedule for that. Let's see. It's not my eyes, it's the light. It could indeed be the light, but it's the same lighting I use every week. I'm just not so sure why my eyes are so sensitive to it tonight. I'm not sure. Let's see here. Audience participation and rants is part of the show. I know. I'll do the best I can, Shubas, but you gotta cut me some slack, man. There's just only so many hours in the day. Let's see here. All right, I'm checking the chat room, and I'm not seeing anything out there that only I can handle. So I think at 2 hours of broadcasting tonight, it's time for me to get my jammies and head to bed, guys. I'm tired. It's been a long day. So good night, y'all. We will see you again next week. Take care now.